Today you'll be learning about solving systems using graphs, section 3-1 in your textbook. First vocabulary word we will look at is what is a system of equations. A system of equations is a set of two or more equations. Here's an example. Negative 3x plus 2y equals 8, and x plus 2y equals negative 8. If I wanted to solve this by graphing, I would need to first take each equation and get them in y equals mx plus b form first. When you do so, the first equation would look like this. The second equation would become this. Now the equations are ready to graph. Here's what the graphs would look like. The first equation would start at 4 on the y-axis, and you could go up 3 and to the right 2, or down 3 and left 2. The second equation would start at negative 4 on the y-axis, and would go up 1 and to the left 2, or down 1 and to the right 2. The two lines intersect at this point. Solution of a system, a set of values or point that makes all equations true. These two lines intersect at this point, negative 4, negative 2. To check this as a solution of the system, you would plug that point into both of the equations. For example, in the first equation it would become negative 3 times negative 4 plus 2 times negative 2 equals 8, which would make 12 plus negative 4 equaling 8, which is true. In the second equation, it would become negative 4 plus 2 times negative 2 equals negative 8. This would become negative 4 plus negative 4 equaling negative 8, which is also true. Because that point makes both equations true, it is the solution of the system, the point of intersection, negative 4, negative 2. Let's try one. Finding solutions. Solve the system by graphing. As I said on the previous page, we need to first put them in y equals mx plus b form. So let's take the first equation and solve for y by starting to subtract negative 2x, and we get 4y equals negative 2x plus 12, then divide by 4, and y equals negative 1/2 x plus 3. To graph this, we're going to start by going up 3 for the y-intercept, then we could go down 1 and right 2, or up 1 and left 2. I'm not going to draw the line at this point. I'm going to wait until I graph the other equation to see where my points may intersect. So let's look at the second equation. X plus y equals 2. We need to subtract x, and we get y equals negative x plus 2. So we'll start by going up 2 for the y-intercept, then down 1, left 1. If I continue in that direction for both equations, my points get further apart. So I need to go the other direction to try and find the intersection. So I could go up 1 and left 1, and if I continue that, then I find that the point negative 2, 4 is a point for both equations. So now I can draw my lines for my graph. And then state that the point of intersection is negative 2, 4. You need to check the point to make sure that you have graphed them correctly. So if I plug them back into the original system, I would get 2 times negative 2 plus 4 times 4 equals 12. That gives me negative 4 plus 16 equals 12, which is true. In the second equation, I would plug in to get negative 2 plus 4 equals 2. That is also true. So now I know that my answer is negative 2, 4. Now you try. Please open your books to page 135 and do got it number 1. Remember to pause the video so that you can try this problem, then look up your answer in the back of the book. If you get it wrong, please make sure to highlight in your notes so that you remember to ask questions the next day in class. Classifying a system. A consistent system has one or more solutions. To break it down, independent has one solution and dependent has infinitely many solutions. Both of these would be considered a consistent equation. And then more specifically, you would name it as independent or dependent. An inconsistent system means that it has no solution. Let's look at some examples. This first system that has been graphed would be classified as a consistent independent system. It has one point of intersection, which means it has one solution. What do you think about this system? This system would be classified as inconsistent, no solution. The lines are parallel and therefore will never intersect. If they never intersect, then you cannot find a point to be a solution. What about this system? Notice that there is only one line on the graph. Why is that? When these equations were graphed, they ended up being the same equation, which means they were on top of each other. This would be classified as a consistent dependent system because it has infinitely many solutions. Due to the fact that one line lies on top of the other, they would intersect infinitely many times. Let's look at how to classify a system. Without graphing, classify the system as independent, dependent, or inconsistent. To do so, we are going to solve the equations as if we were going to graph them. Then we're going to look at our equations and try and break them down to decide what are they going to do. So let's start with the first equation. 4y minus 2x equals 6. We're going to add 2x to both sides and get 4y equals 2x plus 6. Then divide by 4 and get y equals 1/2 x plus 3/2. For the second equation, 8y equals 4x minus 12. Divide everything by 8, and you would get y equals 1/2 x minus 3. Notice that both equations have the same slope. So what does that mean? It will mean that the lines will either be parallel or be the same line. So what do we need to look at next? We need to look at the y-intercept. Since the y-intercepts are different, they will start in different points, but go in the same direction since they have the same slope. This means that the lines will be parallel. Looking back at your notes from the previous page, parallel lines are classified as what? They are classified as inconsistent because they will never intersect, which means they will never have a solution. Now you try. Turn to page 137 and do got it 4B and 4C. Once again, remember to pause the video and look your answers up in the back. If you have any questions, please write them down and save them for the next day in class.